Good afternoon. Hello and welcome, ladies and gentlemen, to this webinar from Erlang Solutions on Erlang in Gambling. I'll be talking today, my name's Stephen Goldby, about some of the challenges faced by firms in this market, the catalysts and the things that act as brakes, and also about Erlang and how it's been able to help in certain circumstances. I'll be followed by Dan Macklin, who's the R&D manager at Bet365, and he'll be talking about why they chose and use Erlang. The talk should last something about 50 minutes, 40-50 minutes, and with time for questions at the end. And if you'd like to ask questions, please use the panel at the right side of the screen to enter things in so that we've got some record of what the questions are. Hopefully we'll be able to deal with them all in time. Those that we don't get time for, we'll deal with as written answers as best we can. I should also say that because of the nature of some of the, not necessarily the content, but the business is very much focused on, if you like, cutting edge. So there may be some questions that we simply are unable to answer, just because a lot of it is actually, I suppose, NDA in terms of private and to the benefit of the particular company. Anyway, we like to hear from you, so please ask the questions. So, firstly, this is a very large topic, and it could really cover gaming, online gambling, casinos, slot machines, games, or even multiple online games, sports betting, and inline sports streaming, and whatever else that the suppliers would care to dream up. But in this instance, we're going to try and limit ourselves to probably sports betting, just because of the time limitations. Now, my original image of the bookmaker or high street gambling shop was something akin to the adult bookshop. It's probably not quite the same now, as I can verify, having queued up on Grand National Day behind Lord Lytton Cobbold in the Nebworth offices of the William Hill shop, and I hear all the cries of shame from the Bet365 contingent. And it's a bright and airy establishment with lots of ways to invest your money. And I can confirm that with subsequent discussions with Lord Cobbold that we both invested pretty unwisely on that occasion. But it really is probably giving us an indication that it's more of a lifestyle and an entertainment industry. It's changed drastically from the time that it was a province for the guys in the shabby coats and cigarettes. And there are now new ways to gamble, especially over the internet. Obviously, not just in the shop. And as probably Dan will say later, Bet365, for example, have no shops. They're a purely internet organization. But there are some things that are slowing down this creative or otherwise growth. And I suppose the primary one being legislation. And in England, we have a phrase that is very simply different strokes for different folks. And I guess as the supplier of the service or the electronic bookmaker, pretty much you have to align to whatever each government in whichever country you wish to trade wants. And in basic sense, they probably want money in the form of taxes and levies, but they also want the popularity and the kudos of being seen to control what is something of quite a foremost industry in the leisure market for that country. And another potential source for limiting growth is surprisingly the actual technology itself. If you're running one of these systems, they're not things that you can stop pretty simply. There's little or no concept of, I suppose, real greenfield development because things grow pretty much incrementally. And oddly, Moore's law still applies in terms of cost and power and size, but it's just not easy to string together some sort of a solution on choices that you made a couple of years ago. It's not easy to suddenly change the direction and scale out, as the term is, in terms of new and additional functions. And the other side of that is that the technology, or the ubiquity of the technology and its free availability through things like iPhones, Androids and other sorts of smart handsets just feeds that demand, making it easier to attract new users, which unfortunately just exacerbates the problem, or in terms of the supply, the opportunity. And Dan's got some interesting statistics on this. In short, it's an industry that's in constant change and trying to keep up with the demands coming from the customer base, and also in innovative ways in trying to create new demands. So how can Erlang help in this? Now, we've all suffered that well-meant support advice. But, like WhatsApp, if you've got rather a lot of users out there in the ether, that's not really an option for any central system, whatever the technical flavor of that system. Hence, the attraction of the hot code swap for upgrades whilst running, which is now proving also attractive in this area outside of the normal telephone exchange paradigm. Gaming and betting services are all good candidates for this type of function. Or, I suppose you could consider how your money gets in and out of your bank accounts. Another one of our clients, Vocalink, and there's probably some folk out there listening from that customer, are now live on an Erlang-based money transfer switch in Singapore, which went live earlier on this month. Now, from a simplistic viewpoint in terms of concurrency, there's no need for any of the developers to have any access to or specific knowledge. All of the concurrency and single threading problems that are faced by normal developers is all a given. They don't need a knowledge of that at all. And in the same way, there's no shared memory between any of the applications because of the basic stateless nature of all of the applications and nodes. And the virtual machine, or the Erlang virtual machine, can make use of, or full use of, all of the cores available. And this is pretty much, again, why somebody like WhatsApp could use pretty standard multi-core hardware with new applications spinning up as demand dictated. And the final point on there is really just to show that as well as being industry tested, there are a lot of continuing developments and innovative applications being built to actually operate in and around the Erlang virtual machine. So what do we do as Erlang Solutions, and what do we bring to the table? Pretty much as you see, with many different clients working to use the appropriate skill sets that we have, but each client presents different business issues. So there's not really a one-size-fits-all. And pretty much we end up being active in both architecture, design, confirmation, proof of concepts for areas where new technology is being introduced, new messaging infrastructure, the provision of REAC, a key value store in a new SQL arena and its implementation, server design and creation, and obviously training, because in many instances the people that we come and talk to don't have much knowledge of Erlang in the first instance, so we're able to train them so that they can become self-sufficient and looking after their own projects as time progresses. Pretty much as you'd expect from any professional services organization, really. So the people that we're working with are potentially gaming companies, advertising provision and brokerage companies, simple messaging firms, payment companies, travel companies, as well as gambling companies. So our expertise has grown along with the use of Erlang over the past years, really. So let's hear something from Dan about the path that Bet365 have taken in adopting Erlang. Over to you, Dan.
Thank you, and thanks for letting me have a talk to you today. If I show my screen, start seeing my slides. So, to start with, I'm going to give you a bit of background about Bet365 as a company, which I think is fairly obligatory for these things. Then I'm going to spend a bit of time describing why we as a company felt we needed to change. Then I'm going to go through some of the things that we found when we started using Erlang, some of the results we got, and how we got the business to adopt Erlang as a mainstream platform. Now, I'd like to start by saying we're pretty excited, and I'm pretty passionate about Erlang. And the title of this talk, We're Raging with the Machines, basically sums up that passion in that at Bet365 we want to be the best. And we want to use technology to its fullest to satisfy and make sure that our customers have the best user experience. And the summary of this talk is about how Erlang potentially helped us get there. So if I start off by describing a bit about us. So Bet365 was founded in a porter cabin in Stoke-on-Trent in 2000. It's a privately owned business. Basically, the Coates family own the share capital of the business. Last financial year, and we're coming towards the end of the financial year now, over £20 billion in sports bet were wagered on our site, which I think makes us about the biggest online bookmaker. Some people might disagree with that, but I think that's the case. We employ 2,500 plus employees, and we have our own software development team, which is about 300 strong. We also have our own IT infrastructure team as well. Last financial year, we spent more than £60 million a year on our IT budget, and we have about 2 million plus concurrent users logged onto our site on a busy Saturday or when a busy event is running. The main thing is, which is good for my employees and good for us as a business, is that despite this growth since 2000, we are still growing rapidly. So how did we do that in 13 years? Well, the answer is Bet365 is all about being innovative. We were the first company to do in-play betting, so that is betting on the who wins the next goal, who scores the next corner, so it's betting on how the match is actually going. We were the first to push our data changes to clients rather than using polling technology. We were the first company to do in-play streaming, which is basically you can watch your event as on the site as you're seeing the odds and all the data changing. We were the first to do something called Match Live, which is like a mini version of a game running in the corner of your web browser, so you can see who's doing the most attacks and how the game is going without watching a live stream or being there. You might have seen our Ray Winston TV ads. We were the first people to put live odds inside of TV adverts, and from a commercial perspective, we were the first company to do the best odds guarantee. So, what's the technical challenge at Bet365? You know, what is special about us? Well, my boss kind of summarized it as a busy day for us is like Black Friday at Amazon, but Amazon don't change their prices every second. So our job really is to trade events of fast-moving data and get that information out as fast as we possibly can with as low as latency as we possibly can to our customers, so that they can place a bet on it, and by the time that they place that bet, that information is still valid as in it's still actionable. So innovation and scale, how have we done that up till now? How have we grown from a company, you know, in a porter cabin up to the size that we are now? Well, historically, we've been very pragmatic, and we've very much focused on our customers. And what I mean by that is we haven't really, up until this point in time, needed to use any exotic platforms or anything like that. We've been a pretty traditional development house. We're lucky enough to employ some really great people. Because we're privately owned, we get to make good decisions, but most importantly, they get made quickly. As I just said, we tended to use mature development platforms, Java, .NET, SQL Server. We obviously spend a lot of money buying the best kit, and we've always done everything ourselves. So basically, we run our own data centers, we develop our own software. If there's anything to be done, we pride ourselves in doing it ourselves. And most importantly as well, we're prepared to learn from our mistakes. When you want to get something out there first, it's unlikely you're going to get it right first time. And the business has a very forgiving attitude to a certain level about making mistakes and learning from them and building better software because of it. So the question you might all be asking, Dan, that sounds fantastic, you know, amazing. If all so brilliant, why are you bothering to change anything? You know, it sounds like you've got it made. Well, the answer is multi-core. in that we're starting to go beyond what's possible using traditional tools and techniques, and we're starting to run into this thing that I call the innovation scale dilemma, which is that once you start getting a certain number of customers or over a certain number of customers, you lose the ability to innovate quickly because you're constantly rewriting your software so that it runs at a scale needed to run the business. The flip side of that is any time that you have a new innovation, you spend so long trying to get it to scale that you can't get that innovation out of the door. And as the most important thing for us is about being first to market, and we've got such a big user base, we want technologies that help us break this innovation scale dilemma. So, because you might have noticed this talk was about Rage Against the Machine, we started to ask bigger questions of our platforms, and in the politest possible way, they started to say, no, won't do what you tell me. So we had to do something about this. So about 2 years ago, the senior management set up a R&D team, which I manage, and they attempted to get, and they succeeded, some free-thinking people from varied backgrounds to join the team. They put us outside of the day-to-day concerns of software development, and they basically tasked us with seeking out, testing, and proving and evangelizing relevant, kind of disruptive or sustaining technology. Basically, anything that will make a really big difference, which isn't something that's proven, where there's a high risk of failure, they basically had put it our way. So once the team was formed, we were given a task, and probably the most important system in Bet365 is about getting data to customers quickly. So the biggest problem that we have was finding a better way to solve this in-play, pushing data out to customers problem. So what is in-play? Well, in-play is effectively the mother of all pub sub-problems. So what we've got is we've got our trading teams. Our trading teams run tools. Those tools work on markets. Those markets are constantly changing, and what our job is to basically push that information out to push that information out for many thousands of events to many millions of customers as quickly as we possibly can. So the legacy or historic in-play system that we were running was a highly concurrent distributed system running over hundreds of servers. Basically, as I said before, it pushes updates to customers rather than them having to poll for data. When something changes, we ping it straight over to them. It supports or supported TCP/IP and long poll clients, and it was originally based on a proprietary Java solution. So why did we change? Well, we wanted to break from the pack, and what I mean by that is that we really live in a copycat economy these days. When one person comes up with a good idea, the rest of the industry tends to follow pretty quickly, and we started to see that happening. So what we wanted to do is that we wanted to build an infrastructure that allowed us to be really innovative so that we could break away from the competition once more and start wowing our customers by offering, really great new innovative products. As part of this, we started to note that because of the scale innovation dilemma, our innovation was slowing. We were spending a lot of time constantly re-engineering stuff. We saw limited scalability options inside of our Java solution, and tuning each system was just taking forever. Testing the system was becoming a nightmare as well, because rather for each time that we wanted to scale the system out, it ended up getting more complex as we started using more esoteric kind of multi-threading techniques and stuff like that. And reliability. With the Java-based system, it didn't go wrong very often, but when it does go wrong, you really want to get it back up alive as fast as you can, because in this game, time really is money. The longer something isn't working for, the less people are able to bet on it. So what did we do? So we basically sat down and we defined the attributes that we wanted for our new push platform. So the short list of these were we wanted a different approach to concurrency. No matter which way you dress it up, multi-threaded programming is very, very difficult. So we started thinking about the actor model, and that looked interesting. And obviously, there's the whole kind of immutability thing. We wanted whatever platform we have to be a basis for innovation. So at Bet365, we want to do things well, we want to do things quickly, we want to do them first, and we want to do these things at great scale. Plus, we also wanted to be reliable. So, when you run a scale as such, you've got to accept that things will fail, but you want to be able to recover quickly, preferably so quickly that no one ever noticed that something had gone wrong in the first place. So we also had some other attributes. We really wanted to try and use some proven technology. So whilst as a company we are very willing to take risks about getting new stuff out there, we prefer technology with pedigree. Ideally, we want something open source because one of the ways we've got to where we are is by having a very, very deep understanding of how everything in our technology stack works. If we've got an open source solution and something's broke, we can get in there, fix it, and then tell the community about it. Complexity. We wanted to drive innovation by solving complicated problems in a simple way. So we want to keep everything as simple as we possibly can. And plus, we're a big business. We've got a massive operations team out there. We want to be able to upgrade stuff quickly. We want to have good monitoring. We want to be able to scale out when one of our new products is really, really successful. We want to be able to scale out really quickly. So once we'd defined the attributes, we then started looking at our current system to understand it and went to the market to see what we could find. So as all good research teams, we went onto Google and we asked Google to find me a simple, scalable, reliable multi-core platform. And because we're really thorough, we also tried Bing. And the results for that came back that, hey, maybe we should start looking at this functional programming. Now, back in my university days at Aston University, I did a bit of Miranda, and I can't basically say that I remembered a lot of it. So I kind of knew a little bit about functional programming, but when we started looking at it, I was kind of like, oh, this looks a bit difficult. So I asked everyone else in the team, has anyone else done any functional programming? And despite the fact that we were three thinking people from varied backgrounds, no one else had done any functional programming in depth. So we started looking at it, and it started to look like a different way of thinking. And some of the syntax in some of these languages or ways of doing stuff, started looking a bit scary. And then I heard people say, oh, it's a bit like Excel. And in the back of my mind, I don't know about you, but I absolutely hate Excel. So then we looked at it a bit more, and we found out, well, actually, functional programming is more about transforming data than writing procedural code. You describe what you want to do rather than how to do it. And when we started writing a couple of programs, we noticed they tended to be smaller, simpler once you got your head around the syntax. In Erlang especially, as I'll go into a bit, we found it much easier in our Erlang code to reason about concurrency. And also, with functional programming as well, it tends to be easier to control side effects. And if you can control side effects, then ultimately, your software is easier to test, which again, is obviously a good thing. So we also then started thinking, okay, well, what are the alternatives? If functional was like a disruptive technology to us, how can we leverage existing technologies that we're more kind of used to solve these problems? So we had a quick look at Node.js and Go. We had a look at further sharding out our infrastructure. We use SQL Server quite a bit here, so we had a look at a Microsoft technology called Hackathon. We thought, well, why don't we use some concurrency libraries like Akka or Tasks or TPL? But we came to the conclusion that to carry on would lead to more complexity. Each cycle of trying to make it more scalable added more complexity, and the more complexity you get, the more likely you are to fail, in our opinion. So basically, going to the matrix, we saw the imperative as take the blue pill, carry on with what you're doing, and try and make incremental changes to make it better. Or we'd start looking at the functional approach, we'd take the red pill and dive into a new world that we don't fully understand yet, but we'll try and do something radical to change the status quo. So again, why did we do this? Well, it's my belief that as an R&D team, it's our job to spend time looking at what we don't know rather than what we do, and the functional side of it was something we definitely didn't know, so that piqued our interest. So once we decided to start looking at functional programming, we had to decide which functional programming language was right for us. So we started to pull back the veneer, look for the hype, so to speak, and find out what the source of all these good ideas in functional programming were. And at Bet365, it's very important for us to try to use the right tools for the job. So we wanted to identify those right tools. So fairly quickly, we came across 4 different things that we were going to look at a quick shortlist. So there was Scala, F#, Haskell, and Erlang. Now, Before I go on talking about what my views are as to what these different technologies, I'm very much in the belief that you can do amazing things in any of them, and it's more about the people that you have and how they use that technology than the technology itself. But because I've been asked, I'm going to give my views on the different technologies anyway. So Scala, we took a look at it, and I've got to admit, when I first started learning Erlang, when I was sat in Centre Parks, when my wife was out with my daughter doing some bike riding or making a birdhouse or something, I sat down with Learn Some Erlang website, and it looked really complicated. In fact, because I wasn't actually programming at the time, it was so complicated, I started learning Scala instead, because I thought, well, I'm a Java programmer, Scala will be relatively easy to get my head around. But then I started reading about it, and I started reading a general purpose, multi-paradigm, object-oriented functional language with concurrent elements. It sounded to me, wow, it sounds like they're trying to do an awful lot on that platform. It sounds like there's going to be lots and lots and lots of different ways of doing the same thing. And so I went to a couple of conferences, and I heard people talking about the amazing things they've done in Scala, and indeed, a lot of them seem to be saying, whoa, you know, there's a lot of different ways of doing the same thing. Now, in Bet365 world, we want to do things in the best way, and we want to do them quickly and get things out simply. Sitting around the cooler having long debates about how we're going to get this out or what is the best way of doing it is probably something that, you know, we want to try to avoid if possible. Because Scala is a bridge language, as far as I'm concerned, we didn't think it was a true functional programming language, so you could still, you know, program in a non-functional way. I've already said that it lets you do lots of things in lots of different ways, and, you know, we thought it was quite complex, and, you know, I've only got a small brain, it made my head hurt. So then we started looking at F#, which, you know, at a top level, we believe was Microsoft's version of Scala. And, you know, so I don't bore you, it seemed to have many of the same attributes as what I just discussed. Then we looked at Haskell. Now, for either rightly or wrongly, we kind of thought Haskell was a bit kind of academic and, you know, didn't have that length of pedigree, although in the commercial space, for us to really want to spend much time adopting it. So we kind of saw that as the Beard's choice of functional programming. So we had a quick butcher's at it and then moved on to Erlang. So Erlang, we took a look at it, and as I said back in Centre Parks, yeah, if you're not used to it, the syntax can be a bit interesting. But it's got this very mature virtual machine. Now, it's a functional programming language, yet the developers of it were trying to solve real problems, so they were pragmatic. They put things in like process dictionaries and binaries where when they go over a certain size, you know, you have reference pointers to them, things like that. It supported this actor-style concurrency that we'd heard so much about, and it seemed to be one of the first platforms to adopt that and actually use it in great depth. It's got this concept of lightweight processes, which effectively means that you can spin up a process really, really quickly. So, you know, you can have programs running on relatively moderate kit, which have, you know, millions of processes running. Had this kind of let it crash kind of mentality. So what it means by that is that you write your programs so that they fail, and then once they failed, you get them to recover as fast as you can. Also had this library called OTP, which was is a really good wrapper around kind of like the actor model that is basically the default way of solving concurrent or stateful problems inside of Erlang. I also looked a bit more, and it had this this simple garbage collection. And back from the Java world, you spend an awful lot of your time working with garbage collection. So to have something with relatively simple garbage collection was good. Now, really importantly, Erlang is not new. Now, you might have noticed I said earlier that we like technologies with pedigree. Erlang has been battle tested within the very demanding telco space since the 90s. So in fact, if you look back on it and if you look at the job that a telephone switch has to do, you know, the engineers at Ericsson who were building this were dealing with the very same kind of concurrency and high availability problems back in the 90s that we are looking at now. So, you know, this is a technology that's been out there for a long period of time and has been very successful in that space. We found that Erlang did pioneer and harden a lot of the ideas used elsewhere. We were very encouraged to find that there's a lively Erlang community out there. There's lots of websites, there's lots of forums, there's lots of people to ask, there's lots of GitHub projects springing up around Erlang. And it had the best movie with by far the best hair. So Erlang the movie, you can Google it, it's out there, it's fascinating. You know, you can trust a computer scientist who looks like Joe Armstrong did there, and the other guy. So you know, it really won on the beard slash interesting hairdo front. So given these facts, we decided to try Erlang, and the question that we were trying to ask ourselves is, could we believe the hype? So we basically set out to test ourselves. So we selected a major part of our push platform, and we decided to re-engineer it in Erlang and get it to a standard where we could get into production. So up to this point, we've written a couple of test POCs, but this was a really serious one where we had something that was measurable and we could compare it to something else that was out there. I'm a big fan, much to the consternation of my superiors, of giving projects stupid names. So given that it was a push project, we decided to call it Real Good after the Salt and Pepper Push It Real Good song. It was a direct replacement for a Java component, so as I said, we could measure it. And that Java component had, you know, it could handle about 25k connected users on one of our servers running at full production load. So we had a target out there that we wanted to beat, and we wanted to prove this Java system process around about 200,000 incoming messages per second to process them to distribute to those 25,000 users per server. So, you know, we went away and we boffined and we sweated and we learnt Erlang and we learnt the internal systems. And after about 2 months, we found that my team of 6 were pretty comfortable with Erlang. They really liked it. And, you know, we were able to, although re-implementing a system isn't the same as discovering it from scratch, that always takes a lot longer. You know, the powers that be were pretty impressed that we managed to implement a much more scalable version of a system inside of 2 months. So the results from that was that we were able, you know, without an awful lot of performance tuning, get 125,000 connected users into our system at 4 times production load. And if we were able to run at existing production load, we were able to handle 500,000. So that means in 2 months, we were able to take a system and we were able to scale up to 5 times the user connection scale and 4 times the rate of data change. And the most important thing, and the thing that we I really liked about it, is that in our Java-based solutions, we'd have these, you know, 32-core, you know, big boxes, and we'd run HTOP on them and stuff like that. And no matter what we did, they'd only be using, you know, 7 or 8 of the cores, and it was really hard to drive better core usage of our software. Erlang wasn't like that. We were able to drive and work those existing boxes far harder, which we thought was a really good thing. So after 2 months, the R&D team, you know, were pretty much sold. But then came the really big problem, because if you've got a business and you want to change the way that it works, you've got to engage. You've got to get the rest of the business to come with you. You've got to get other people excited about what you found. And having a good POC is only part of the problem. Getting a whole team of developers to adopt something new, learn something new, you know, it is a fair task. So this is really how we went about it. So in order to get people, we engaged. And so we are predominantly focused on our Java programmers, and we needed to convince them that Erlang was in their futures. So how do we go about this? Well, first of all, I tried being nice to them, but you know, they're clever guys. They saw through that pretty quickly. You know, they were fairly impressed by the movie. You know, the facial hair and Robert Verding and all that, and Joe Armstrong messing around. You know, that made them go. We tried begging, pleading, bribing didn't work. So we basically set out to prove something about Erlang. So the things that, you know, we want to do as a company is that we want to inspire our programmers to do the best that they can. So we're looking to make programming fun. We're looking to reduce frustration of having to constantly re-engineer the same code over and over again. We wanted to prove that Erlang scales to them and is reliable. We wanted to prove that Erlang has enough depth to be interesting. And, you know, that is quite a problem with technical people, in that, you know, when they're used to dealing with multi-threaded problems and they're dealing with all these concurrency libraries, there's a lot of depth to that. And you've got to, you know, psychologically, programmers have to find depth in something and have to be interested in it to, in my opinion, do a good job. But the core to that is that we've got some really difficult problems to solve, and we want to do it in a simple way. So we want to prove that Erlang has both depth, but coupled with that, you can do a lot of stuff simply. We wanted to prove to them that Erlang utilizes hardware resources effectively, and as I keep going back to it, we wanted to solve this innovation scale dilemma. We want to be able to get our software out to our customers as fast as we possibly can, and we want to lead the marketplace. So we decided to use our proof of concept to engage with the other teams, and fairly soon we found that the production teams soon started to appreciate the benefits of Erlang. They quickly developed their own, or co-invented their own implementation POC, which has actually been live now for about a year. Now, I've got an interesting thing about technology adoption. Most of the programmers don't want to go back to Java, and I see Erlang adoption a bit like Stockholm Syndrome. You show it to people, and at first they're like, oh, really hate this, which is the same as kind of being abducted in a strange way. But eventually, as they get into it, they start to love their captor, and by the end, they completely and utterly, love it to pieces. And so, given that Erlang comes from Stockholm, I think that's well, I think that's fairly funny anyway. But yeah, most of our developers, once they get to grips with Erlang, do not want to go back to Java. Now, we did our implementation of our POC within around about 2 months or so, but the actual production teams got their solution live in record time. And since going live, to my knowledge, we've had no major problems. The main thing is asking the guys as well since then. They do, in fact, spend a lot less time reworking for scale. So, all in all, pretty successful. So, like an engagement summary before my pre-summary, so to speak. Once programmers get going on Erlang, they tend to love it. Programming in Erlang is fun and, dare I say, fairly addictive. Erlang does make effective use of hardware resources, and our results so far show that Erlang is reliable. We were able to replace a key piece of our infrastructure in record time and get it live, and we found out fairly much that you can believe the hype. The only small caveat that I would put on it is that when people really get into Erlang, they think they can solve all the world's problems in one go, and so sometimes you go in there and enforce a little bit of realism, because people get pretty carried away, and they can tend to go off on one. But other than that, and that's a management problem, the platform is pretty sound. So last slide, you'll be pleased to know. I don't know how I'm doing on time. We think that Erlang helps developers rage with the machines rather than against them. So in our old world, we spent lots of time forcing our machines, all of these servers, to do things that they didn't really want to do, and we found that Erlang is against that. It basically allows us to work with concurrency, to work with the hardware and infrastructures that we have. And so basically Erlang's about innovation, it's about multi-core, that leads to happy customers and continued great success. And if you're an Elixir programmer, you'll understand the syntax there. And the next thing that we're looking at as part of our R&D effort is Elixir, which is a language that runs on top of the Erlang VM. So I don't know if I've gone ahead of time, but that's my my slides over. So so basically onto the questions. So,
well, thanks very much for that, Dan. It's very interesting. We have had some questions come in, most of which look reasonably answerable, I have to say. So first off, it was to do with, I think it's, forgive me if I get the names wrong, my display of who's asking the questions is in about 4 characters vertically, so it's not exactly, it's more intuitive than factual. Anyway, from a gentleman called John, he's asking, did you look at something called flow-based processing in conjunction with functional programming? Does that ring any bells with you?
By flow-based processing, does he mean complex event processing, or does he basically mean message passing? If he means complex event processing, that's an area I'm quite fascinated with, and I've written an Erlang-based CEP system outside of work myself. We do tend to use CEP quite a lot for a number of different things internally, and I see that as going forward that we will. But with regards to looking at any of the other technologies other than in superficial depth, then I've got to admit, no, we were quite lucky in that we started looking at Erlang, and then we fell in love with it fairly quickly. So hope that kind of answers the question. But yeah,
Well, yeah, I guess so. I mean, there's I think there's another there's another association with that, saying did you did you compare, or how did Akka compare in terms with, or when looking at specific native scheduling, or was that something that ever came to light?
yeah. Well, our Java team basically, Akka is basically a Java kind of threading library. And again, I would love to say that we sat there and we did great in-depth analysis and implemented the prototype in many different ways. No, we didn't. As I said earlier, I think that there is always many different ways of solving the same problem. But we just lucked out, I suppose, to a certain extent. And the Erlang one was so much better than our Java one that we haven't really looked elsewhere. And it's so much better in terms of it's just the simplicity of the end implementation was so good, and the results were so good that when we went and presented them back to the CTO, he just said go for it, rather than re-implement another prototype in using Akka. But I can see that that Akka uses the same message passing semantics, so it's a perfectly plausible way of doing it. I suppose you've just got to watch that you're running on the virtual machine, and so it takes a little bit longer, I suppose, to spin up different processes, and you may have some garbage collection issues. But again, that's just me speaking on hunches rather than from any position of real knowledge.
Okay, no, thanks for that. I mean, there are a number of questions from, I think, from Alan and another John, relating to persistent storage. They're saying, what sort of database choices have you made, if you've made any choices at the moment? I mean, you're currently talking about the actual language that you're writing the applications in. So, over to you.
Basically, yeah, traditionally we've been a SQL Server house. We think that there are many different NoSQL or new SQL technologies out there, and we would look to use the best tool for the best job. But the predominant one at the moment that we're using for the use cases for our systems in this area is React, and we're pretty happy with React, simply because its implementation is simple, it's open source, it seems to do what it says on the tin, and we've proved pretty good horizontal scalability for the use cases that we have. So, and it's written in Erlang as well. So once you get good at Erlang, you can look at some of the code and see how it works, and dig deep down into the solution. And we found Basho to be quite a good company to work with. Okay. So I'd say for the projects that React would be the main one. But I've looked at kind of Couchbase and chain replication and all kinds of weird, wonderful stuff. But I think React has the most traction at the moment.
Okay, there's a question from Mikhail, which is a bit perhaps more sensitive in terms of, it's quite a simple question actually, but it may not be whether you're comfortable with it or not. He's just asking, what were the machine specs that were handling the 500K throughput?
All I'll say to that is they weren't anything really special. So they were commodity kind of hardware. It wasn't any kind of weird, wonderful Tylera or anything like that. It was pretty commodity stuff.
Okay. A question from I think it's Eugene in South Africa. So I suppose you've answered this in some ways, but he's just questioning how easy, or was it easy, to train the non-Erlang developers with Erlang. I think you've probably covered that, but
basically, it's a case of getting back into the mindset of where you were when you tried to teach them. So we've built an internal Erlang training course which covers the basics in around about 2 days. We find that as long as you get people typing and solving problems in it quickly, then you tend to pick it up pretty quickly. I think the mistake that a lot of people make is that they sit there and read all the books, and a lot of the books, there are some very good books like OTP in Action and stuff like that, but some of them can be a little bit dry. And if you're not used to the whole paradigm of functional programming, you spend a lot of time sitting there going, well, why do I need an atom? Why do I need tuples? Why do I need this, that, and the other? Whereas if you just dive into it, I'd recommend to anyone the Learn You Some Erlang website is pretty good. But dive into it, and yeah, you've just got to give people a little bit of time. we tend to find that after around about 2 weeks intensive using Erlang, most people have got the basics. I think when you look at some of that Erlang from the outside, you think it looks really complicated and a bit of a nightmare to start with. But once you get past that initial hurdle, you get to see that it's actually quite simple under the hood. And it really does, when you get used to it, allow to break down your logic into very, very small components, which are very easy to test and very easy to reason about. So yeah, there's a little bit of upfront, whoa, this is a bit different. But as soon as you can get people past that by actually doing some programming, we found, and with your guys, Erlang Solutions support as well, there in the background, we haven't really had any, we got the initial, oh, I don't want to do that, but 1 week, 2 weeks past, when people actually got past the mental hurdle of learning something new, we really had no problems with it.
Okay, thanks for that. There's a question, I think, from Ivan, who's asking, besides the paradigm change, which is or was the most single difficult issue in Erlang for a mainstream developer? And what did that make sense?
Yeah, I think I know he's asking, what's the hardest thing to get your head around? I still struggle with supervisors, because they're the kind of thing you set up, and then the supervisors are the thing in Erlang that restart your processes or start your processes when something crashes. And I've got to admit, I always get the syntax of them wrong, and I always forget how to do them, and I'm forever going back onto the web, and I'm forever recompiling my stuff and scratching my head. So I would say supervisors. I'd say that some of the deeper parts of the Open Telecom platform, which is OTP, which is basically one of the central libraries, and one of the things that if you're programming in Erlang, you really, really, really want to get your head around. So you have this concept called a gen server, and inside that gen server you pass it messages in, and you basically have a state object that sits there. And again, when you first do that and you're using supervisors to start them, you will get it wrong many more times often than when you get it right. For people who are interested in Elixir, I find the simplifications that they've done in the Elixir language make it much easier to deal with supervisors. But again, it's just one of these things that you write your first project, you get your supervisor hierarchy set up right. Now, your supervisor hierarchy is something that you really want to spend a lot of time planning, because that gives you your quality of service inside of your application and gives you your reliability. But that's the bit I found hardest, and that's the bit I think my fellow people in R&D find hardest, because every time we come back to do a new one, we've kind of forgotten how to do it. But again, the OTP in action, the Learn You Some Erlang books will give you everything that you need to know to get a robust first implementation that you can, although I won't recommend using those templates, you can use the template to get you going and then customize.
I should interject at this point and thoroughly recommend the book from also Francesco Cesarini, my technical director, in terms of learning Erlang, for fear of being sacked for it not being mentioned.
I will want that.
Quite right. And there is another question here, I think, from Richard. This may be a bit more tricky, saying, his question is, what Erlang components did you use in terms of trying to produce the push module to push the data to the web browsers?
Well, obviously we used OTP. We didn't use any databases or anything like that. I'll be honest with you, I can't go into the innards too much because that would be giving too much away, but we didn't do anything all that clever, is all that I'll say. As in, no custom mods, no, we didn't do anything overly special.
And there's actually a couple of questions around this, but one of the obvious ones, because it really is, I suppose it's a bit like a messaging paradigm. There's a question here: is, are you using RabbitMQ for any of this?
Not for this project at the moment, no.
Okay. Well, I suppose I'll answer the logical question: do you use RabbitMQ for anything?
I can't really say.
Right. Okay.
Sorry.
Did this influence your choice? Right.
I will say, sorry, that I have privately played with Rabbit. Rabbit's also written in Erlang. I do think it's a very good technology.
Yep. Okay. I think you've already explained how you actually train the team. That's like the questions have appeared subsequently, but I think you've already been through that. One question that I'll add is that there is a lot of talk about Elixir, and I think I've watched a presentation from Jose Vadim. It's a very interesting concept, but as the user, or as the person who's faced with the problem, why would you use Elixir in one instance and Erlang in another? Well, what's the differentiator?
Well, Elixir basically is a different syntactic layer that compiles back to core Erlang, I think, and runs on the Erlang virtual machine. I think if you came from, we're a .NET Java, mostly .NET but Java house. If you were a Ruby-based house, then you'd probably find it a little bit easier to pick up Elixir. Basically, they formalized an awful lot of their APIs and standardized them, and they have added some kind of basic OO to it in a way, as in they've got this kind of protocol thing going. One of the good or very bad things about Elixir in my personal book is that it allows you to write macros, and so just like Erlang can be used if you want to get into Lex and Yak and all that kind of stuff to build DSLs, it is easier to build that kind of stuff in Elixir. Basically, in Elixir, it looks a little bit more like Ruby, as I've said, and when you create functions and stuff like that, you've got your def, you don't have to export stuff. They've got some libraries in there that basically makes supervisors a lot easier to deal with. I think it really comes down to a choice of syntax, and the syntactic elements of Elixir are more up to date than Erlang, but which is best? As well in Elixir, there's some Unicode optimizations. I think there's some performance optimizations under the hood. I have used both of them extensively. My gut would say that if I was starting a new project, it would be 50-50 for me which one I would physically take. I think my gut would say that if you learned Elixir and you didn't learn Erlang, you would definitely be missing out on something. But both of those tools can be used to achieve the same thing. I would just be very, very wary of macros, because you can get a bit carried away in them, and you think that the best thing is sliced bread, and before you know it, you've implemented a bit of a monster. But Elixir is definitely that pipe syntax I showed there. One of the things in Erlang is when you're chaining functions together, you tend to do them back to front. So you call a function which then the arguments are another function, which the arguments are another function, and so your code can sometimes look a bit back to front in that you have to go down the stack to see what's going on. Whereas Elixir has things like this pipe operator that basically allow you to say, I'm going to do this, and then I'm going to pass the results into that, and so you can chain your functions so that it looks like they're running in the right way. So yeah, I think it's a very exciting space. I think the Elixir people have done a very good job. I think it's something that we may adopt more as time goes on.
Okay, thanks for that. There's a question here relating to the IDE. Is it, and this is, again, I don't think it should be too contentious. I mean, do you use Emacs or in IntelliJ or anything else?
We use a variety. To be honest, I am a Vi man with no syntax highlighting or anything at all, because I'm a really old kludger, and with Emacs there's too many keyboard shortcuts that I forget. But we like the IntelliJ Erlang plugin, and we've also used the Eclipse plugin inside of the Erlang Eclipse plugin. But so yeah, the different teams who are specialising in different things in the company will basically pick their weapon of choice, so to speak. But I use Vi. I don't know, it's probably just ruined my life out on the internet, but I'm a Vi man.
Okay. There's a question here. You may be comfortable, you may not, and I'm not sure. It's the question is pretty much, what's the operating system that I guess the Erlang virtual machine is running on?
All I say is a standard Linux distribution.
Fine. And the other question associated with that was, did you have to do any I suppose lower level hacking within that system to actually get better performance out of Erlang?
Well, you have to understand the basic architecture, and so we spent a bit of time looking at NUMA architectures, and how basically you can, because a lot of things when you're dealing with a lot of TCP/IP stuff, you get a lot of background work, and you have to peg cores to certain things. So we looked at NUMA, but did we write any esoteric code? There's the WhatsApp guy has a presentation out on YouTube somewhere where they're talking about them instrumenting the VM and writing all kinds of C drivers and stuff like that. We didn't really need to do any of that.
Yeah, well, I suppose it's easier if you're optimizing for one specific function, really. Then you're not going to really put loads of other stuff in danger that you're not really concerned about.
But it was more OS level config kind of stuff rather than I see that more as configuration than hacking.
Yeah. Okay. Another question here. This is generic. Are you aware of any of your gambling competitors using Erlang?
I think they probably are.
Right, I couldn't possibly comment. We do, I mean, in a generic sense, we do have several customers who are in the gambling space. This is Erlang Solutions, and we do help them with both Erlang type developments and indeed other technology stacks as well. But I'm also aware that there are several institutions that do have Erlang, not base solutions. They may have some components running in Erlang, but they're not really our customers. They've pretty much rowed their own boats and gone off and done all this stuff themselves anyway. So yeah, I mean, there probably are. There's probably more than you think. It's like financial trading. There's more institutions using Erlang at probably control plane level than is immediately apparent. Most people always associate high frequency trading with some vastly complex and fast stuff written pretty much directly down to the chipset. But something overall, and there are several institutions here in the UK and the US that use Erlang as a means of trying to control all that stuff and making sure that it's all working to whatever optimum criteria they set. Anyway, let's see if we can, enough of the advert, let's look at see if we can find another one. What about, there's a question here about analytics, reports, etc. for risks and other departments. Is that still the province of SQL? That's a question for
now. Yeah.
Yeah. I mean,
basically, when you're adopting anything, you want to try and solve one problem at a time.
Yeah.
So for now,
okay.
I think so. Yes.
Well, okay. There's another comment here about, is the pattern matching in Erlang any use in fraud detection?
Yeah, well, from a previous life, yeah. Well, I love pattern matching. It's one of the central, probably should have mentioned it, so it's one of the central concepts of Erlang, and it's what I think allows you to build lots of small functions. It's one of the most powerful things. But you can do pattern matching on binaries as they fly by. So I think the classic example that's out there on the internet is decoding frames in an MPEG-4 video using binary pattern matching. I can't stress enough, pattern matching is incredibly powerful for writing network level protocols and for structuring your code inside of an Erlang application. It's one of these things that's just really, really good about it.
Okay. There's a question here from Alan. Do you have any specific tools to interpret Erlang crash logs?
No. I can't remember. There's an open source project. I think it's called Recon. That the guy who wrote the Learn Some Erlang course, which we're not using in production, but it certainly looks interesting. Yet one of the first things when you do start using Erlang is using some of the crash log. It takes a bit of getting your head around, basically. But I'm not aware that anyone inside the company is using any special tool. We just use our custom enterprise logging frameworks to log stuff out to our data collection kind of stuff, and we use that. I'm not sure that we've done anything special in terms of looking at the logs, but when you first see one and you're used to a Java stack trace, it does make your head hurt a bit. But eventually you get to use them. I think we tend to use although that's not a crash log, we tend to use Lager, which is a Basho library for all of our logging.
Okay. There's another question, more to do with something I raised earlier on, I guess, in that somebody's asking, do you at Bet365 actually use the hot code swapping facility within Erlang?
We might do. Basically, if you want to keep your systems up to, we're Bet365, not Bet36.4 or whatever, and so consequently, availability of systems is paramount to us. Ideally, you want to be able to structure your system so you don't necessarily have to do hot code uploads and stuff like that. But I don't think I'd be giving a game away if I said that we have done that.
Yeah. There's a question here about, also I suppose a bit related to that in terms of an earlier one. Do you have any specific tools to visually monitor the, let's try and read it, the health of the OTP system, which I guess means Erlang nodes and things like that?
We tend to use the standard OS level tools for actual monitoring our software, and then the Folsom library, which is written by a company called Boundary, I believe, which is an open source project. Again, is quite good for stats collection. And then we tend to just basically put those stats into a format which is web readable, and then we import that into our other enterprise systems.
So you'll be looking forward to using Wombat OAM then?
I have heard about that, and I've read the PDF, but we haven't gone too much further than that. I know that Francesco was wanting me to look at that. I'll be honest, I've been a bit lax in that area, but yes, that kind of infrastructure sounds very interesting.
Yeah. Okay. All right. Well, I'm conscious of the fact that we've already run over the hour's time. It looks as if we have quite a number more questions to answer, and I don't think we're going to sadly get through them within a reasonably short time. Thank you very much for your time, Dan, and for the insights, not only about what course Bet365 took to get to exactly where you are, but also for the answers. I think the answers themselves are actually just as interesting in terms of it sheds a lot more light in terms of knowledge and judgments and criteria and stuff like that as to why you did something. So thanks again for that.
It's a pleasure.
And we have we try to run these seminars every 6 weeks, or sorry, webinars I should say, every 6 weeks or so. We think we have another one organised for later on towards the end of April. However, we haven't got a confirmation from the person concerned at the present time, so I'm not really able to say who that is. I would ask you, all those who are still patiently listening, that if you've got any ideas that you'd like a webinar on, that would help us to format that in terms of a specific topic, then we'd be very happy to listen to them. Or if you have a topic regarding Erlang that you think it might prove interesting to others, please let us know. The slide that we've got up has got Mladen's name on it, but you can send anything to the webinar at Solutions, as it says there. Mladen, unfortunately, or fortunately for him, is on holiday for today, so he normally does this job, and I'm a mere deputy for the man. But anyway, thank you all very much for your time and listening, and any comments, please send them in. We're always happy to hear from you, and as I say, we will try and answer the questions that we haven't gone through on air and get written answers back to all of those people who've posed the questions. The webinar itself should be online through our site sometime later on tomorrow, so those who'd like to listen again, please do so. And thank you very much for all your time, and goodbye.
Thank you.